Good morning, children. We'll start with a new chapter today, that is the parallel lines. Okay, so first of all, let us understand what are parallel lines. Okay, so two straight lines. Okay, so two straight lines are said to be parallel. Okay, so any two lines are said to be parallel if they do not meet whenever they are produced in both ends. Okay, produced means to elongate. Okay, so whenever we elongate this line from both the ends, okay, and if they do not meet, however, till wherever we extend, till wherever we produce, if these two lines do not meet, do not cross over each other, then those two lines are named as parallel lines. Okay, so these two lines are parallel because we have tried to produce, we have tried to elongate them in both the ends, but they are not meeting at any point. Okay, so these two lines are parallel. Okay, so let us see another pair of lines. Suppose this and this are two lines. Okay, and let us produce these two lines. So if we produce these two lines here and again here and again here and here, you see here these two lines are meeting, right? Whenever produce, these two lines meet here. Okay, so in that case these two lines are not parallel. Okay, so in short we can say that two lines are parallel if they do not meet whenever they are produced or whenever they are elongated. Okay, so for example, let us see a railway track. Okay, so a railway track lies in this way. Yes. Okay, so whenever we extend to any end, it does not meet. Okay, so these two tracks are parallel to each other. Okay, so if you see the pillars of your house, yes, so the pillars of the house lie in such a way that whenever they are elongated till any end, it do not meet. So the pillars of your house are parallel to each other. Okay, so this is the concept of parallel lines. That means they do not meet whenever they are produced or elongated. Okay, so before we discuss about the various properties of parallel lines, I want to give you an introduction about transversal. Okay, so I hope you all are very familiar with this word traverse. Okay, so traverse is an English word which means to cross over or to move on, right? Cross over or not move on, pass on. Okay, so traverse means to cross over or to pass on. So same way transversal also has certain similar meaning to traverse. Okay, so transversal is a line which crosses over any two other lines. Okay, so transversal is nothing but it is a line. So what kind of line is it? What kind of line is named as transversal? Then the line which crosses over any two other line is named as transversal. Okay, so you see this third line, let me name this line as L. Okay, so this line crosses over these two lines, right? The two lines need not always be parallel. Okay, if we have this line and this line, and there is another line which crosses over this line, then this line is also called as transversal. Okay, so if you look at the book, then the definition will be more clear. So transversal is nothing but a line which crosses over two straight lines. Okay, so that is called a transversal. Okay, so if you have these two lines and a transversal, then you see there are certain angles formed, right? You see an angle formed here, you see an angle formed here, here and here, right? Here also you see an angle. Okay, so when two straight lines are cut by a third line, which is a transversal line, then it forms certain angles. Okay, in particular it forms 8 angles. Okay, then these angles which are formed by the transversal line, it possesses some properties and some names. Okay, so we'll learn one by one what are these angles, what are these properties. We'll discuss. Okay, so let me name this angle. So when a transversal cuts two lines, then remember it forms exterior and interior angles. Okay, so there are 8 angles formed whenever two lines are cut by a transversal. Out of that, 4 of them are exterior angles and 4 of them are interior angles. Okay, so I'd like to draw the exterior angle at one side and interior angle at the other side. Okay, so so the angles which lie inside the two lines, okay, the two straight lines are this and this. The line which the angle which lies inside the two lines, that is this angle, this and this. So which the angles those are inside the two lines are named as interior angle, okay, because it is inside. And those angles that lie outside the two lines, then these angles are named as exterior angles. Is that clear? So these are the interior angles and these are the exterior angles formed. Okay, so apart from being exterior and interior angles, these angles have a certain names. Okay, so let me do this. So let me name this angle. This is angle 1, 2, 3, 4, 5, 6, 7, 8. Let me elongate this a bit. Okay. So these are the 8 angles formed when two lines are cut by a transversal. Okay. So there are certain names that these angles possess. Okay. So first name is alternate angles. Okay, see children, you should be very confident in recognizing which angle's name is what. Okay, once you recognize the names of the angle, the properties will help you to solve the problems that you get in exercise. Okay, so alternate angles. So whenever you look at alternate angle, remember that we always see just the interior angles. Okay, I repeat, whenever we talk about the alternate angles, we just talk about the interior angles. So interior angles here are 3, 4, 5 and 6. Okay, the angles that lie inside these two lines. Okay, so those angles are which angle? Angle 3, 4, 5 and 6. Okay, so these angles have a name, alternate angles. Okay, so out of these 4, which are the alternate angles? So remember that whenever we name the angle, we always name a pair of angles. 2 angles are named. Okay, so out of this 3, 4, 5, 6, we need to see which are the alternate angles. So remember that whenever we are searching for alternate angle, we need to see the Z symbol wherever Z is formed. Okay, so you see here, from here, here and here. Okay, so I am drawing this point. So here is Z formed. Yes, this and this, right? And another one will be reverse Z. Okay, so this is this and this. So this is this. Okay, so these are 2 Z's that we get here. Okay, so if you see this Z, the angles that we have here is angle 3 and angle 6, right? And whenever you see this reverse Z, then the angle we are talking about is angle 4 and angle 5. Okay, so these 2 are the pair of alternate angles that we have. Okay, so when 2 lines are cut by the transversal, we get two pair of alternate angles. Those angles are angle 3 and angle 6, and another is angle 4 and angle 5. Okay, so these two are the pair of alternate angles. Okay, children, I repeat again how to recognize which are the alternate angles. Okay, so to recognize the alternate angles, you need to just consider the interior angles, the angles that lie inside the two line segments. Okay, so those angles are 3, 4, 5 and 6. Yes, so here out of these angles you need to recognize where Z is formed. Okay, the alphabet Z. Okay, so if you see here, the Z formed is this, this and this. I've drawn here. Okay, and this another Z is the reverse Z. I've drawn it here. And the angles that is included here is angle 4 and 5. Okay, so these two are the pair of alternate angles that we get. Okay, now we have another pair of angle. I'll draw this once again. 1, 2, 3. So this is 1, 2, 3, 4, and this is 5, 6, 7, 8, 3 and 6. Yeah. Okay. So now we are talking about another set of angle, that is corresponding angles. Okay. So number 2 that we have is corresponding angles. So whenever we look for corresponding angle, remember that we check for the position. Okay, so the position that corresponds to each other. Okay, so if you see here, so I'll draw this separately. I'm drawing only the upper part. Okay, I just want angle 1, and here I just want angle 5. Okay, so if you just look at this diagram as just this, then you see this angle and this angle 1 and angle 5 correspond to each other in position. Okay, so here angle 1 takes whichever position, the same position is taken by angle 5. Okay, so same way if you see the angle 2, whichever position angle 2 takes here, the same position is taken by angle 6. So all this angle which takes the same position is named as corresponding angles. Okay, so the angles that are corresponding angles are angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 7, and angle 3 and angle 8. Okay, so children, there are 4 pairs of corresponding angles. Okay, so corresponding angles are determined by the position that the angle takes. Okay, so you see angle 1 and angle 5 lies in same position, 2 and 6 same way, 4 and 7, and 3 and 8. Okay, so these are the pair of corresponding angles that we get. Okay, so this is all about alternate angles and corresponding angles. So I'd like to quickly revise. We have discussed about what is a transversal. So any line which crosses over 2 lines is named as a transversal. So whenever 2 lines are crossed by a third line, there is a set of angles formed. In fact, 8 angles are formed. These angles have a certain name, right? So we have alternate angle and corresponding angles. Okay, so when we check which are the alternate angles, we just see the interior angles and look for Z symbol. Okay, so we have 2 pairs of alternate angles, and corresponding angles are determined by the position of the angle. Yes, so this and this are corresponding angle, this and this are corresponding angle, this and this are corresponding angle, and this and this are corresponding angles. So there are 4 pair of corresponding angles. Okay, so this is all about the introduction part. So I'd like to request all of you to try question number 1 exercise 3, that is page number 18. Okay, so if you have understood this video, then you'll be able to solve this question number 1 from your exercise. Okay, if not, then please watch this video again. Okay, so after going through this video, you should be able to solve this question number 1 very easily. Okay, thank you so much.